me a shout if there's a problem.
Right, continue.
Okay. I was talking about Gavin Lamont, who was at UCT, did his PhD there with Alex de Toy. Then he went to the Geological Survey in Southern Rhodesia, then in Geological Survey in Bechuanaland, and then joined De Beers in 1955. And he soon realized the importance of termites bringing grains to the surface, as had been suggested by the Eugene Moret, who wrote a book about termites called The Soul of the White Ant. Certainly a book that's worth reading if you're interested in this sort of thing. So Gavin Lamont decided he should sample the Kalahari, so he designed a sampling strategy with using a large sample team with a team leader, a wheel pusher, guys taking samples and porters. And he cut north-south lines in the bush about 10 miles apart, and the teams would walk for 5 miles down, 1 mile across, and 5 miles back. And that would be one-day work. And they would take a spade, a scoop sample every 15 paces. These would be combined at 0.2 of a mile when the wheel pusher blew his whistle, and the 2 bags would then be combined as one sample. They would be, after 6 samples would be taken back after 1.2 of a mile to the traverse line, and these would then be put on the truck. The truck would move a mile to meet the back-coming sample team. And in that way, they covered thousands and thousands of square kilometers in Botswana. A very labor-intensive exercise, but very, very efficient. There is the scoop sampler, the guy taking a sample. He puts it in a sample splitter. The sample, half the sample goes out, the other sample gets into the bag, and every 0.6 of a mile, the 2 bags get combined as one sample. And in the front, you had a guy pushing a wheel, and on the wheel, he had a little chronometer, and he would measure the distances, and he also had a compass in his hand, so he would keep the guys in the right direction. So that's the way that Gavin Lamont, covered the sampling. Then he took the samples back to camp, and initially they were using gold pans to concentrate the sample. Now they were looking for those heavy minerals that I showed you in the first slide, the garnets, the ilmenites, and the chrome dioxide, and diamonds if they were there, because they are all heavy minerals, so they can concentrate in a gold pan. But it turned out that that wasn't a real, very efficient way of concentrating minerals. The better way was to screen the material first, take out all the very fine clay and fine sand, and then concentrate the screed material in a jig using screens. And that turned out to be a much better way of concentrating the minerals. So the first thing that the Beers did is they went back to the area where Consolidated African Trust had found their diamonds, and they resampled that area in a very similar sort of way, stream samples along the main rivers, and they had some very similar results. They found 2 diamonds in very much the same places as Selection Trust had found, but they also, with this more efficient screening analysis, found garnets, ilmenite, and chrome dioxide. So minerals that would identify itself with kimberlites. So that was a major step forward, and Gavin Lamont for a long time had argued that they should sample more to the west, but having been there since 1955, it was 1962, they hadn't found anything in Botswana yet. Anglo De Beers decided that they didn't want to take out more licenses at the time, and they carried on working in the eastern part instead of going across. There's the upward axis that I mentioned from Alex de Toy. The diamonds are found in the Mkrutsi River, and that's the X marks the spot. That's Orapa area south of the Magadi Pan. So the argument was that the drainage had come actually from much further west, but that the axis had, the upward axis had cut the drainage off and and therefore had cut off the source of the material found in these rivers. So in the meantime, Gavin Lamont carried on sampling in the more accessible areas, and in 1966 did find the first kimberlite-looking rocks not too far from Gaborone, called the Machudi kimberlites. And this brings in the third person who was quite involved in the discovery of diamonds and kimberlites in Botswana, a gentleman by the name of Chris Jennings. He was an ex-Italian, played rugby actually for Natal, and he joined the Geological Survey of Botswana 2 years after Gavin Lamont had left it. But being a small place in Botswana, everybody knew each other, and they got quite well on in the beginning. Chris Jennings was mainly into groundwater, and he was very much involved in developing geophysical techniques to establish, to drill for groundwater for Botswana as it was developing itself. But in 1971 joined a company called Falconbridge, and in 75 proposed to sell Falconbridge to start looking for diamonds in Botswana. So it basically became opposition to Gavin Lamont. But in those early days, Gavin approached Chris Jennings and asked him if he wouldn't do some test surveys over those newly found kimberlites that I mentioned just now at Machudi, to see what technique would be best for kimberlite exploration. And they used various methods. They used ground magnetics, ground gravity surveys to measure density differences. They used electromagnetics, they used IP, and used potential. They even used seismics. But in the end, they concluded that magnetics was a simple and effective way of exploring for kimberlites. So then in 1966, and the pressure was now on from Anglo De Beers to start, they considered pulling out of Botswana at the time because they'd been there more than 10 years and they had found, except for those two little bodies near Gabs, two small kimberlites. They decided to go across the upwarp. There's the upwarp, that's the Maklutsi drainage, and there's the Suapan with the Orapa kimberlites position. And they decided to do a quick and dirty. Gavin Lamont took his chief geologist, Jim Gibson, and the two of them went on a crude road sampling exercise in this area. They took 17 bulk samples, scoop samples, on sheets 21, 25A and B. That's really why we're calling these kimberlites AK1 and BK2 and BK3. It's the second, third, or fourth kimberlite on that map sheet. So I will refer to these AK1s and BK2s, etc. But they spent a few days sampling, and they discovered that 12 of their 17 scoop samples were highly positive with ilmenite and garnets. So they knew they were onto something. And let's just note the date. This was in July 1966. And in September that same year, the Botswana gained its independence. And one of the things that Sir Seretse Khama, who became the first president of Botswana, one of the first things that he did was to convince all the tribal chiefs that they should surrender all the mineral rights of the tribal lands and put it into under one as a government mineral rights. So basically, he said, let us share any wealth we find underground with the whole nation, irrespective of where it was found. And he was a man of great vision. In March the following year, following up on the results that Lamont and Gibson got, and of course, the first thing that they had to do is get some licenses. They got the licenses, and it wasn't very shortly thereafter that the young South African geologist Manfred Marx found the first kimberlite in the Orapa province. It wasn't the one that's going to be mined, but it was the first kimberlite, and it was a great success. And in the following month, BK2, that's the kimberlite on the map sheet B, was found in March, and then on the 25th of April was AK1, which is really the big find of De Beers, and which became the big kimberlite mine. And to celebrate this 50 years later, we had a celebration conference. Manfred came back from Australia and went into the PK1 pit and just posed for this sort of celebration. It was a great highlight. Anyway, so the big kimberlite was found, the first positive sample of AK1, April 1976. These are the guys that were involved in sample processing. They had a little lab. They used a little bit of bromoform there to separate the heavy minerals. And the first sample produced, and these samples weren't very big. They produced well over a couple of thousand ilmenite, a couple of thousand garnets, and many, many chrome dioxides. And it's really a sign that you're almost on top of the kimberlite. Gavin Lamont then actually sent me the first grains that were picked and found from Orapa. I still got them here at home as a memorandum. If you look at the air photograph of the time that before the discovery, and this is an air photograph in 1957, the discovery was in 10 years later, you can see the outline of these kimberlites. That's AK1. That's about 1.5 kilometers by 1 kilometer wide. Those are some of the other kimberlites that they were finding here in Orapa. And these kimberlites, there was hardly any Kalahari cover here. These kimberlites stood out as really nice features. And in fact, the AK1, that feature was used by SA Airways when they flew to London as one of their beacons on the way on their flight plan. So there is Gavin Lamont with Manfred Marks and Jim Gibson, the guys who really opened up this part of the world. It didn't take long to get the first samples out of the kimberlite, and these were small pits that were dug to 20 feet. They used a very simple plant that they got from Kimberley. You must remember, exploration in a mining company is always the one that gets a squeeze on, so you do everything as cheap as low cost as possible. This is a rotary pen that the diggers use on the rivers, and this was used to get the first diamonds out of the sample. Later on, they used the more advanced equipment, some headgears and a DMS plant. Anyway, so the first diamonds that came out, there's a photograph of the first diamonds from AK1, and it became big news at the time in the world. They then decided to do some airborne magnetics over the whole area, and this is a Catalina aircraft that came from Canada, and it was really the first airborne survey that was done for kimberlites, and they flew these on flight lines, and you can then pick up the magnetics, kimberlites having a slightly different magnetic signature than the surrounding country rock. And that's what the Orapa kimberlite looks like. It's now sitting at about close to 400 meters deep. And with depth, it's actually developed in two big pipes that's sitting on top of one big crater. And when this thing exploded, it left behind a big hole in the ground and filled with water and so on. And it was like a crater lake almost. This is what it looked like in 2017, 3 years ago. There you can see these are fairly big drill rigs for scale. And that's there you can see the development in the one pipe and their development in the other pipe. It's 118 hectares on surface. And it has produced, since discovery, has produced well over 400 million carats now. This particular pit is probably now close to 300 meters deep. And the grade of this kimberlite runs at about 90 carats per 100 ton. So you have to mine 100 ton to get 90 carats out of that. The kimberlite itself is 95 million years old. It's what we call part of the Cretaceous, and it provides a great employment for the Botswana government. What is interesting is that I mentioned it had a crater on top, and in the crater it had a crater lake, and there were some really interesting fossils that were found in these craters, in this crater, with some very nice insects and beetles. and also some plants and some flowering plants. And it was just about the time that the flowering plants and the fruity plants were developing in the Cretaceous. And it provides a very interesting story, the relationship of these beetles with the remnants of these plants found in this crater. Unfortunately, they mined away the crater, but we were able to collect quite a number of fossils, and there's quite a number of papers that have been written about that. The mine was opened in 1971 by Sir Kama and Harry Oppenheimer. And one of the things that they decided to do is to build a Botswana mining company in which the government and the Beers each had a 50% shareholding. It's something that was unheard of, but by these two, both these guys with tremendous amount of vision, it still is a very remarkable relationship. Sampling continued, and I'll just run through it a bit quicker now. This is in the Jwaneng area. Initially, the sampling in 5 years prior to that, people had sampled close to the Jwaneng area, had found nothing. But in 1969, they started sampling this area, and they started picking up a lot of ilmenite. The difference here with Jwaneng area and Orapa is that the Jwaneng area has a cover of about 50 meters of Kalahari sediments. So this is really where the termites is coming in. They've brought these grains to surface, and this is a map showing the density of the number of ilmenites per sample, and you can already see the outline of potential kimberlites. They found these what we call heavy mineral anomalies, and they brought in a rig. They drilled the first targets and found nothing. And it's interesting that again, the drill that they used was a drill that they had in Orapa. In Orapa, you don't have any cover, but the depth limit of this rig is 50 meters. The cover at Jwaneng is 50 meters. So that's really why they missed the first holes, missed the kimberlite. But they pushed this rig a little further and then drilled into their first kimberlite at Jwaneng. They found at least 9 kimberlites initially. I'm not going through all the details here, but the people in control there was a chap called Stuart Verco, and he had a team with Norman Locke. They were the two people that were really involved in the discovery and evaluation of that kimberlite. So interesting, Jwaneng is actually 3 lobes. So it's got 3 pipes. It's about 54 hectares in size, about half of Orapa, but still very large in terms of general kimberlites. And the first drilling that was done, they had to go through the Kalahari sediments. They used a jumper drill, and the jumper drill is a machine that has a big chisel. The chisel hammers away, it bounces up and down, and it goes down fairly slowly. Every now and then you have to pull out the chisel and then put in a baler. The baler goes down and picks up the material, brings it out, and then the chisel goes down again. So the penetration rate of this drill was fairly slow. Initially about 5 meters per shift, but that certainly at depth started changing to about 1 meter per shift. And it was far too slow to do the evaluation drilling. In addition to that, the hammering of this chisel resulted in quite a high percentage of diamond breakage. And of course, that is not good for evaluation purposes, because you lose your value on your diamonds once you start breaking them. So this was replaced with rotary drilling, and they've then managed to complete the evaluation program. This is what Jwaneng looked like. It was 54 hectares. It's a bit older than Orapa. It's about 240 million years old. It was commissioned in 1982, and it's almost produced as many diamonds as Orapa has at the moment. There you can see how it's covered by quite a lot of Kalahari sediment. So it's quite a lot of stripping that had to take place before they could actually start mining this ore body. There you can see the 3 lobes. This is now at depth. This pit is now almost 700 meters deep. It's a massive mega pit almost. Its grade, it's also much higher than Orapa. It's sitting at about 130 carats per 100 ton. But note the value of the diamonds. On an average, about $200 a carat, and the cash cost is about $90 a carat. So you can see the revenue of this mine. It's probably the richest mine of any commodity in the world. That's the size of the pit. It's a large pit now. There's the photograph of the pit. And to give you an idea of the depth that they cut what they call cut 8. Cost $3 billion to open cut 8, because you have to take out quite a lot of country rock to get to the kimberlite now. And it's twice the height of the Eiffel Tower. That's where we're sitting at the moment. And the production, this mine produces between 12 and 15 million carats per annum. It's really one of the biggest producers and Orapa together. The cost I mentioned was $3 billion to make that cut down to that level, and that'll take the mine through to 2028. But this is the sort of revenue that this contributes to as a country. Enormous amount of funding that the country has developed, and also the number of people that it employs. And you can see that in the country. All the roads are paved. There are some good hospitals. There are good schools. The money is really put into the right professions. Obviously, one of the problems that you're having with these steep pits is failures. This was a failure in 2012, which set the production back a bit. But generally, Jwaneng has produced not only a lot of diamonds, but also some very beautiful diamonds. This is a 236 carat diamond that was sold for $19 million or 90 million pounds in 2013. It had produced a 446 carat stone in 1993. And it's probably produced a lot of big stones, which we don't really hear about much because it's not De Beers' way of doing business. Just to continue a little bit further, the big mines in Jwaneng over here, Orapa here, had been found, but the law in Botswana is such that if you take out a license, you do prospecting there, and then you drop the license, you have to hand in your results, and these are made public, so people can go into the Geological Survey in Gaborone, it was in Labatsi, but it's now in Gaborone, and you can take out. You can look at up reports, and you can then build on that. And this is what these people did. They looked at all the sampling that De Beers have done. These hatched areas are areas that are covered. The cross hatches are areas where they found positive samples. But because De Beers were so busy in evaluating their Orapa and Jwaneng deposits, they didn't have time to follow up some of these other areas. And this is what Falconbridge did, Chris Jennings and the guys. They took up these areas where De Beers had found positive samples, and instead of sampling, they had a very different approach. They used airborne magnetics straight away, and were able to find lots of kimberlites in a very short period of time. Lots of kimberlites at Sabong, at Kokong, and even here in Gopi in the Central Kalahari Game Reserve. So their approach was very different, and they discovered many, many more kimberlites. Unfortunately, none of those ever became a mine, except there's a kimberlite in Gopi in the Kalahari, Central Kalahari Game Reserve, and they, for the first time, used a helicopter to do the sampling. They sampled on a grid, and in 6 months, they were able to cover this whole central area, which De Beers would have taken a couple of years to do by foot. And they found numerous kimberlites, among others, this Gopi 25 kimberlite. That's what Gopi 25 kimberlite looks like. It's got about 80 meters of Kalahari cover, so a real challenge. It's about only 10 hectares in size. You can see these kimberlites are getting smaller. It's got a grade of about 27 compared to Jwaneng of 130, and it's got 80 meters of cover. So a very different economic kettle of fish that's set and developed for a long time, and I'll get back to that in a minute. Just to other kimberlites that contain some diamonds right on that central eastern part, close to the border with South Africa. A couple of kimberlites were found there. They contain some diamonds. They don't have any cover. They were mined for a couple of years, but they really don't, because of the quality of the diamonds they didn't turn out to be economic, and they were dropped. But one thing that has happened, certainly in the last decade, is that people have started looking at some of the kimberlites that were found by De Beers and other companies and re-look at them with new technology. And this is what we call AK6. It's the Koroa mine also in the Orapa area. After the initial discovery, it was thought that the kimberlite was only 3.3 hectares in size. But it turned out that this kimberlite is much bigger, and it's because the part of the kimberlite has got some vessel capping on it, and therefore you don't see it with magnetics. And so some of these kimberlites have been re-looked at. The grade of this kimberlite was initially thought to be 3 carats under ton, turns out to be a lot more than that. And this particular kimberlite, AK6, have produced some of the world's magnificent diamonds. This is a 1,000 carat stone, 1,100 carat stone that was found in 2015 in this mine. That stone was sold for $53 million, one diamond. This one was found almost in the same week. It's an 800 carat diamond that was sold for $63 million. And more recently, they found an even bigger diamond, but obviously not as clear as the other two, of nearly 2,000 carats. Now, the biggest diamond ever found was the Cullinan diamond in Premier Mine in Pretoria. That was over 3,000 carats. That's now part of the crown jewels in England. But it's very rare to find, and almost impossible to find these big stones, not just because they're so rare, but also because mining operations tend to break these diamonds at times. This mine has produced, as I mentioned, 2 diamonds over 1,000 carats, 6 diamonds over 300 carats, and so on. It's not a great producer. It only produces about 200,000 carats per annum compared to 12 million carats for Jwaneng, but it does produce some of the best, nicest looking diamonds that are around. And some of the things that they have introduced, they don't crush the kimberlite rock. They use a heterogeneous milling technology, which is much more gentler on the diamonds. And they also have an X-ray transmission facility that allows for quick passing of coarse material that can pick out any big stones early on before it goes through the whole metallurgical process. So this technology has certainly helped them to find and preserve some of these big stones and preserve some of the value of those diamonds. The Gopi 25, which I mentioned early on, with the 80 meters of cover, the company did try and put a decline in through the 80 meters sediment to the kimberlite. It worked for 2 years, but they had a lot of water problems. You can imagine this is 80 meters of Kalahari sediment, soft sediment, through which they tried to shaft, and it was disbanded a couple of years later in 2017, and it was recently sold to a local group that be interested to see what they're going to do with it. So in summary, this is when the first, this is just a graph to show you the number of kimberlites that were found in Botswana over time. The first 10 years was really De Beers doing most of the discovery, and it includes the Orapa and the Jwaneng pipes. And then Southern Era had a big go at it. They found lots of kimberlites, unfortunately nothing that was mineable, and so on. So there have been phases, but one can see how it slowly tails off, that most of the country has been reasonably prospected. But I think there is great potential to still look for other kimberlites using more modern technology. So when the next when the diamond market picks up, I'm sure there'll be more interest doing that. And this is the final slide that I just wanted to show you. This is shows you what it's done to Botswana as a country. The GDP in 1970 was $84. The GDP at 2018 is now over $8,000. And that's really what it's done for the country. it's done a massive injection of development, and you can see how the GDP has performed against that of Zambia and Zimbabwe, which is probably not surprising. But the money is used in very effective ways. They've really upchecked their education system. They've got several universities, 2 universities now. Schooling is of a high standard, and Botswana is a very peaceful and great place to be. So I think that's all I have to say. I probably went over my time a bit. Thank you.
Excellent, Mike. Thank you very, very much. That is fascinating. I don't know whether you're more of a historian or more of a geologist, but certainly that introductory part was also very interesting. You know, there's an annual or biannual Alex de Toy lecture series.
Yes,
and
that's right.
We had, I think it was 2 years ago, where we hosted the series here in Hermanus, and the hall was packed. It was a wonderful explanation of some of the things that Alex has done. So he certainly is one of the great geologists of our time. I want to ask you 2 quick questions, please. I didn't realize that the Cape Val Craton extended all the way into Botswana.
Well, the Cape Val Craton does extend in Botswana, more in the southern part, but there's another craton that has been welded onto the Cape Val Craton that's called the Zimbabwe Craton. And we sort of called both of those together the Kalahari Craton, and in between you have the Limpopo, what we call the Limpopo Belt. So it's not just the Cape Val Craton, it's 2 cratons really that are being welded together that produces the well. And in fact, the Orapa kimberlite punches through the Zimbabwe Craton.
Now, how do they mine? Do they blast and then just scoop up the remain, or is there a different way of mining? And secondly, once it's done, how will the area be rehabilitated, if at all?
Well, if a kimberlite is normally mined as an open pit initially, so they will mine that like Orapa and Jwaneng, those photographs I showed you, as an open pit. But of course, your overburden stripping ratio becomes too high, and then you have to make a decision whether you can continue open pitting or whether you should rather go underground. And a lot of mines then go underground, like the Kimberley mines in Kimberley now, and Venetia in Limpopo has just gone underground. And these mines as well, the open pit will go to 2028. They're talking about another cut 9, but after 2040, I guess they would have to think about going underground. So then they'll continue underground mining. There's different techniques. I'm not a mining engineer, but a lot of that technology is applied in Cullinan Mine and Finch Mine and places like that. So that's a fairly standard technology. With regard to with rehabilitation, it's very rarely that you can fill in these holes. You saw the talk of Marsfontein. Marsfontein still stands as an open pit full of water. And I think you can actually make quite a nice environmental, an environment there for birds and for all sorts of other things. I can only recall one kimberlite that was filled in, that is the De Beers mine in Kimberley, which was next to the railway line. And the railway line there was a chance the railway line was going to fall into the pit, so they had to fill that in. But it's not regular that they fill these holes.
Okay.